Okay, let's do this guy. Pulleys part 2. We have a pulley. This one is frictionless, massless, and this block has a coefficient of friction, M1. We're given the mass. We're given the masses of both. A. Draw a free body diagram for this mass. So let's draw the mass, and this guy's on a surface. First one we want to do is F of G. I know the mass. I know it's on Earth. So that is F of G, mg. Opposite that, we have a normal force because it's on a surface. And this thing isn't moving up or down. Okay, looking at the picture here, we're going to assume it's going to accelerate down that way. And so this mass M1 is going to accelerate to the right because this is connected with this rope. Okay, so call this tension, the rope's pulling on it, and what's opposing tension is the force of friction. So that's it. There's 4 forces on this block. M1. Okay, that's 2 marks according to this. B, what's the acceleration of the system? Or sorry, what's the acceleration of mass 2? Well, it doesn't matter. It is the system, because as this goes down, whatever number this is also moving right at the exact same rate. Okay? So what I want to do is think, this whole system, which is connected with this rope, these 2 masses, it's going to go down because of the weight of this guy. The force of gravity is pulling on this mass, and that wants to go down. Now it is possible that this friction would be high enough so that this wouldn't happen, and I guess you could argue if this pulley wasn't frictionless, who knows, maybe that could be rusted solid and it wouldn't move at all. But that wouldn't be a very fun question. So what's stopping this from just free falling at 4 times 9.8 is the weight of friction on this guy. Okay, so as an actual formula, that's what it is. That's Newton's second law. The unbalanced force is what causes the acceleration. So the unbalanced force here is mg from this weight, so 4g, and what opposes this motion? Nothing here, nothing here, but this guy over here, the force of friction. Force of friction is mu Fn. I know mu, that's 0.27, and Fn, because this thing isn't moving up or down, this force is balanced with this one. So Fn is 2 times, I don't really see that, but there we go, 2 times 9.8. Force of gravity on M1. Okay, that's the only 2 arrows I have on this guy. Doesn't look like an arrow, looks like an umbrella. In this direction, which causes the acceleration. Now the only tricky part is, with the pulleys, this mass is the mass of the entire system. So that's 4 plus 2 kilograms times g. Okay, even if this was frictionless, if there was no friction here, it makes sense to think that the more mass this would have, the slower this thing is going to accelerate, right? Okay, so even if there's no force here, we have to take this mass into account. That's where we take it into account. Okay, so what do I have a G there? That's acceleration. Put that in our calculators. 4 times 9.8 minus 0.27 times 2 times 9.8 G, same thing. Okay, that's 33.908 is 6 times A, so divide both sides by 6, and that's the acceleration of the system. 5.65, and of course that's in meters a second squared. Alright, so that's the acceleration this thing goes down at. That's the acceleration that this block goes right at. And every point on this rope, okay, I don't care where, every point's going to accelerate at 5.65. So I added another question in here. C. Speaking of rope, what is the tension? Find the tension in the rope. So we've learned that it doesn't matter where I'm talking. The tension here is equal to the tension there. It's the tension here. It's the tension there. Okay, because that's Newton's third law. If this thing's pulling with a certain tension, then this is pulling with an equal but opposite force. So to do this, either mass I want to analyze. Let's analyze this guy. Let's change my color. Okay, let's look at this mass right here. That is 4 kilograms, so I know this thing is accelerating down now at 5.65. What's causing that acceleration? It's weight. And what's slowing this acceleration down? The tension in this rope due to the friction of this guy. So, just looking at this mass, the same formula, I have 4G minus T, that's the unbalanced force. That's what's going to cause just this mass to accelerate. Okay, so that's what this says. F net is ma. M, I just want to use this mass, and acceleration, I now know, is 5.65. Solve this for T. Put T over there to that side, and it's positive. Put this over here, and it's negative. So my tension is equal to this minus that for, wish I had a G button in this calculator. That's tension, 16.6. Of course that's a force, it's in newtons. Alternatively, I could look at this mass. I already have a free body diagram for this guy up here. Okay, so tension should be the same, shouldn't it? This is mu Fn, otherwise known as 0.27 times, because that's a 2 kilogram mass, 0.27 times 2 times 9.8. Now this guy is going that way, so tension is bigger than the force of friction. So I want to go and subtract force of friction from tension, and that's what this mass times the acceleration is. Okay? So to solve this for T, I just need to add this stuff. Okay? It's gone there, add it to that side, and I better get the same answer. Plus 0.27 times 2 times 9.8. And I do, 16.6 newtons. Which is what I expect, because the tension is the same anywhere in the rope. Should be all you need to finish that last hound out we have.